Converting graphs is one of the most confusing things for many students in physics. And today I'm going to show you a very simple method to convert any graphs in O-level or A-level physics. Right, so I'm Jing from the A1 Physics, where I teach secondary and JC physics tuition. And right now I'm going to show you how to convert any graphs in physics. Let's go. Now, the very first thing is that we've got to memorize these two golden rules. The gradient of a displacement time graph gives us velocity, and the gradient of a velocity time graph gives us acceleration, right? These two things we got to memorize, and the rest of it will be very easy. So in the first place, what's gradient? Right, gradient is basically the slope of the graph. So gradient, there's two parts. Number one, is it positive, negative, or zero? And number two, is it constant, increasing, or decreasing? Right, positive gradient basically means that the graph is sloping upwards. Negative gradient means that the graph is sloping downwards. If it's a zero gradient, it means that it is a horizontal line, right? That's for the positive and negative part. Now, constant gradient means that it's a constant slope, right? Means that as time passes, it's just a straight line because the slope is constant. So constant gradient can be like this, can be like this, can be like this, right? All of these are constant gradients because the slope is constant, so it's a straight line. Now, increasing gradient means that the slope is getting steeper. So it will be a curve upwards like this, right? As you can see, the slope is getting steeper and steeper and steeper and steeper. Increasing gradient can also be a curve downwards. So over here like this, as we can see, the graph is curving downwards steeper and steeper and steeper and steeper. Right, the slope is actually increasing. Now, decreasing gradient, on the other hand, means that the slope is getting less steep. So it will be a curve like this. Right, as time passes, the curve is getting less and less and less and less steep. Right, decreasing gradient can also be like this. The curve downwards is getting less and less and less and less steep. So basically, increasing gradient means that the curve is getting steeper, and decreasing gradient means that the curve is getting less steep. Okay, so now let's look at how to convert this displacement time graph into this velocity time graph using this very simple gradient method. Right, so we know that the gradient of displacement time graph gives us the velocity. So you want to ask yourself, at these different points, what is happening to the gradient of the displacement time graph, and that will give us the velocity of the velocity time graph, right? So let me show you what I mean. Over here, the slope of the graph is positive. It's positive and it's also constant, right? Positive because it's sloping upwards, and constant because it's a straight line. So my velocity for the first part must also be positive and constant, right? Since the gradient equals to the velocity. So my velocity will just be like this, right? It's positive, it's above the x-axis, and it's also constant. Means that as time passes, the velocity remains the same. Okay, let's look at the next part. Over here, we can see that the gradient, the slope of the graph, is getting less and less and less steep. Right, so the slope is still positive, it's still going upwards, but the slope is actually decreasing. Right, it's getting less and less and less steep. So over here, we can say that the velocity is also positive and also getting smaller. So what does this mean? It means that my velocity graph is positive, is still above the x-axis, but it's getting smaller and smaller and smaller, right? Just like this. Now over here for the next part of the graph, we can see that the gradient, which is the slope of the graph, is getting steeper and steeper and steeper and steeper. So it's positive and the gradient is increasing, which means that my velocity is positive and increasing, right? So positive and getting bigger and bigger and bigger. Okay, so let's go on to the last parts of the graph. So over here, now my graph is sloping downwards, right? So it's a negative gradient. But over here, the line is a straight line, which means that the slope of the line is constant. So we say that it's a constant gradient, which means that my velocity is also negative and constant. Right, negative and constant means that as time passes, my velocity is the same. But now my velocity must be below the x-axis because now my velocity is negative. Right, lastly, over here we can see this one is a bit tricky. Over here is sloping downwards, right? Over here is a negative gradient. But what's happening to my slope? My slope is actually getting less and less and less steep. Right, the steepness of the slope is actually decreasing. So we say that the gradient is actually decreasing. Whereas over here, my slope is negative, but it's actually getting steeper and steeper and steeper and steeper. Right, it's becoming more negative. So over here is actually negative and increasing. So my velocity will be negative, decreasing, and negative, increasing. So that looks like this, negative, but getting smaller and smaller. Right, over here, many students get confused with this, but over here, why is it a slope upwards when it's decreasing? is because it's getting less negative. Means that it's going closer to zero. That's why it's a slope upwards. Getting less and less negative, getting closer to zero. Then now over here, it's becoming more and more negative. That's why it's a slope downwards. And that's how we convert this displacement time graph into the velocity time graph. Also, technically, this graph can be a curve upwards like this or like this. But just to keep it simple, we just treat it as if it's a straight line. Right now, over here we have a velocity time graph and we need to convert it into a displacement time graph. So now we're working backwards, but it's still just the same method. Right, we know that the gradient of a displacement time graph gives us the velocity. So you want to ask yourself, what's happening to the gradient at the different points of the graph and what's happening to the velocity at the different points of the graph. Now over here for the first part of my graph, my velocity is positive because it's above the x-axis. So my velocity is positive and it's also constant, right? Because as time passes, my velocity remains the same. So it's positive and constant, which means that my gradient of the graph must also be positive and constant. So positive gradient means slope upwards and constant gradient means straight line. Right, so it'll be a straight line upwards like this. Now over here, my velocity is negative and it's also constant. Remember over here, I'm not talking about the gradient of my velocity. I'm talking about the velocity itself. Right, over here, the velocity itself is negative and constant. So my gradient of the displacement graph must be negative and constant. So it'll be a straight line downwards, just like this. Right, over here, what's happening to the velocity? Over here, the velocity is positive and increasing, which means that the gradient of my displacement time graph is positive, it's a slope upwards, positive and increasing, right? Means that the slope is getting steeper and steeper and steeper. So it will be a curve upwards like this, right? Now over here, my velocity is still positive, right? My velocity is still above the x-axis. It's still positive, but now it's getting smaller. So it will be positive and decreasing. So my gradient will be positive and decreasing. How does that look like? Positive gradient means slope upwards. Decreasing gradient means the slope is getting less and less and less steep. So it will be a curve downwards like this, right? My slope is getting less and less and less and less steep. Now over here, what's happening? My velocity is negative. It's actually becoming more and more negative. Right, over here is not decreasing. It's actually increasingly negative. Right, from zero become more and more and more negative. So it's actually becoming increasingly negative, which means that my gradient will be increasingly negative. The slope downwards is going to get steeper and steeper and steeper and steeper. Right, and finally for the last part, we can see that my velocity is also negative, but now it's getting less negative. Right, initially it was very negative, then now it's getting closer to zero. So it's actually getting less and less negative. That's why I put over here minus and decreasing. Right, so over here negative and decreasing gradient means that my graph is sloping downwards. That's what negative gradient means, but it's sloping downwards less and less and less. So it will look something like this, right? It's sloping downwards less and less and less and less. So that's a simple trick to convert any graphs in kinematics for physics. So I hope you found this video helpful. As usual, I'm Ting from the A1 Physics. I teach secondary and JC physics tuition in Singapore. If you're interested or you want to find out more details about my physics tuition, you can always WhatsApp the number around the screen over here. See you in the next video.